Okay. Let's revisit funnel and locker criterion again. In the course material week 12 CFA. So for the discriminant validity based on the funnel and locker criterion, compare the square root of AVE for each construct with the correlation between the construct. What does that mean? We do not put the correlation in on the diagonal, right? So we have to put called square root of AVE. So AVE square root, and this one is AVE square root, and this is correlation coefficient. Correlation coefficient. So let's take a look. The CFA we just practiced using the smart pairs again. Let me show you here. Show me here. Smart pairs. Now this value 0.884. Actually, this value 0.84 is the square root of AVE. AVE square root for example, for the additive ADT. And I can show you how to calculate this number again. Okay, now first of all, we need to find AVE. First, the AVE for additive somewhere on your left hand side, you have to click construct reliability and validity. Click this one. Okay. Okay. For additive. Now you can see there's called average variance extracted. So this column is called AVE. This is called AVE, and the additive AVE is 0.782, right? 0.782. So we take a square root. So let's calculate 0.782, and let's compare it to this one. This compared to this one, and I would like to use the calculator. Okay, now calculator. Let me enter the AVE for additive. It's called 0.782, right? 0.782 AVE for additive. Helen, do you see that? I try to calculate square root of AVE. Oliver, take a look. I want to calculate this AVE square root. So the AVE for additive is 0.782 again, and I can take the square root, right? Square root here. Now click equal. Can you compare this number? Yeah? Right. So this cell for in locker following the locker criterion, the diagonal is all AVE square root. And you have to compare this number with correlation coefficient. You have to make sure this number is greater than correlation coefficient. Have to greater than. So square root AVE have to greater than the correlation coefficient. Make sure. So then we can see we can say we have discriminant validity. Let me recheck again the next one. How about behavior intention? Behavior intention, scroll back. Behavior intention AVE for behavior intention, okay, it's around 0.574. 0.574. 0.574, okay. 0.574, remove, okay, 0.574, right? Square root, okay. Okay, so check it. So it's the value here. So in your report, in your third-party report, you have to make a table look like this one to describe the discriminability, okay, for yours based on your CFA report result. Okay. Got it? So that's the correlation analysis. So we can compare to this one, the diagonal value compared to all correlation coefficient. Again, here, diagonal square root of ABE with the correlation coefficient. So for the first column, okay, this one is greater than all of them. So we have discriminability. The next one, no, we fail, right? This one, the correlation is greater than square root of ABE, so this one is fail. Okay, good. Now let's move back. Come to the regression again. So let's call the advanced application for discriminability based on the correlation analysis. And this is the one called Funnel and Locker criterion. The diagonal is the square root of ABE. And under diagonal is called correlation coefficient between two concepts or two constructs. Off diagonal is a Pearson correlation. I have some note here. You can read the note. Note here, diagonal of the matrix display the square root of the average variance extracted of AB for each construct, right? Off diagonal is Pearson correlation between different concepts. Okay. So it's your hint for you to understand. Okay, so this correlation. So probably the correlation between coefficient usually is between -1. The R for correlation is between +1 and the -1. It's the range. Either -1 or in between, or 1 or part equal. This is not possible to equal 1. So usually less than 1 or greater than -1. So in between. And we have to make sure the correlation coefficient, the p-value is less than 5%. So it means significant. Okay, it means significant. Okay, now what is regression? Okay, because the structural equation SEM is based on the regression. It's extend the regression. So we have to understand the regression first. So regression model, as you can see here, we have a dependent variable called job performance. So we have Y, and we have 3 independent variables. We have motivation with social support with intelligence. Okay. So the purpose of the regression is predict the outcome or Y. Okay. So the predictive value is called Y hat. So we have to compare two values, the predict value and the actual value. This one is actual value. Actual y or actual value, and the model will create another column called this a new column called predictive value y. So we can compare the difference between the y and the y hat, or sometimes we call it a residual, or some people call it error term. Okay. So error term or residual is the difference between your actual y and the model predictive y. How to run the regression with this model? Of course, it is SEM. In the smart pairs, we also can run the regression model. But something we have to understand is called the assumption of the regression analysis. It's called linear and nonlinear. Linear and nonlinear. Let me make you an example here. X and Y. X and Y. So we have three scalar plot. This A, this B, this C. Forget about this one. Forget about this one. Only this one. Maybe I need to use the whiteboard to create a new one for easy to explain the idea. The linear model versus nonlinear model. So first one, X and Y, X and Y, X and Y, X and Y. So we have three models. Okay, Jason, there's three model or three kind of relationship between X and Y, A, B, and C.
Yes.
Okay, how to interpret A, B, and C? The relation between two variables X and Y. How to interpret the meaning of A, meaning of B, meaning of C? It's called regression, right? X and only two variables, X and Y. How do you describe the relation between X and Y in A model or in B model and in C model? How do you describe it? Or you only can describe or explain only one? How about the relation between X and Y in model B? Anyone? It's hard, it's difficult to describe. Okay, let me show you here. Okay, in model B, around here, when the x moved from here to here, when the x increase, y decrease, right? Before this cut point, when x increase, y decrease. But after this cut point, when x increase and y increase. So this is called nonlinear relationship. Okay, and this is another type. It's also called nonlinear. So for the C model, we have maximum point in here, and this model for in C we have minimum point in here. And for the first model, it's called traditional linear model. Most of it in our regression, linear regression, is the first one, or the A type. Okay. So this assumption is called linearity. Okay. It will access through analysis of receiver. Okay. I just mentioned about receiver, but how to say that? You can see there's a receiver. There's two different types, right? So it's another terminology. I think in the basic statistics, the instructor or professor already introduced, but it's not easy to memorize, right? So anyway, it's an assumption. You mean the receiver? But what is the receiver anyway? If I have only five data point on the scalar plot, and this x, this y, and I can properly create a regression line here. Where is the receiver? Where is the receiver? Okay, let me give you a hint. A receiver is equal to the estimated, I should say predictive y and actual y. So where is the predicted y? Anyone can identify where is the predicted y? No? Abakari? Okay. Let me use the whiteboard to show you again. Whiteboard here, okay. Okay. Suppose I have a scalar plot. I can draw like this one. I have only 5 data points around here, and I can draw a regression line somewhere here. So the receiver is equal to predict y, and the predict is the gap between is the gap between the predicted y and the actual y. So where is the residual? Can you identify here? Where is it? Where is the residual? Okay. Where is the actual y? Actual y. X and y. Where is the actual y? Yeah? Here, this is actual y, and this one is actual y, right? You can point to here, from here to here. Actual y, actual y, actual y, actual y, actual y. 1, 2, 3, 4, 5. Okay. And where is the predicted y? Predicted y. Where is the predicted y? The 9. Correct. Yes, excellent. Got it. Correct. So it's 9 under 9. So the predict y is under 9. So I can draw here. This is a predict y. So there's a gap, right? There's a gap. This gap is called residual. Okay. So we have different gap here. For example, here, this is another gap. And this is another gap. And this is another gap. And this is another gap. Okay. So there's assumption about the residual and the x. They are independent. 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 So in traditional regression model, it will look like this. This y equal to the intercept plus slope multiply x and plus error term. So the error term is a residual, okay? And the slope is the regression coefficient. This one is regression coefficient. Where is the intercept? Annie, where is the intercept? Where is the intercept? Where? You know, the slope, okay, is the regression coefficient for independent variable. And the error term is the residual, right? Residual. Now where is the intercept? Where's the intercept? How about Winnie? Where's the intercept? Okay. Intercept is this here. Good, it's here. So this is when the x equal to 0, then the y value, okay, this part is called the intercept. Okay. So this is the regression equation. Some people write like this way: y equal to intercept plus slope multiplied by x variable and the error term. So let me rewrite it again. So the y equal to intercept plus slope of x, right, time x, the error term, right, and this part is regression line. Regression line. And equal to predicted y. Okay? This is called regression line, and it's called the predicted y. You can move the equation. If you can move what? The y minus predict y equal to error, right? So this error is residual. Right, it's clear? Good. Okay. So this assumption based on the regression that we need to apply, we have to make sure the variable has a normality. So we have talked about normality at the very first class. We use tests. We use different tests. We also can check the skewness of kurtosis, the statistics about the kurtosis and the skewness to check the normality of the variable. Right? Okay, so now it's called simple linear regression. Simple linear regression, only one x. Only one x or x1. But for multiple regression, we have multiple x, x1, x2, and so on and so forth. So in here, the beta 0, this refers to the intercept. And the beta 1, this is called slope. Okay. And regression have three types. The first is called simple regression, only one x. And the second is multiple regression. We have multiple x, x1, x2. And about the logistic regression. Have you ever heard logistic regression before? Have you ever heard logistic regression? No? This is the first time? Okay. As I tell you that y is a function of x. This y have to continuous and this s have to continuous. So we can apply regression, traditional regression. But what if the y is categorical? What if the y is categorical? Then we can apply traditional linear regression. We need to apply called logistic regression. Categorical means either 1 or 0, or male or female. Something like this, binary, two value in the dependent variable. Okay, so it's called logistic regression. Okay, so metric, scale, continuous. In smart periods, you just notice that, right? In smart periods, we had just used smart periods. They use matrix, right? Refer to the continuous variable. So matrix. Now matrix is a categorical, and also we have two categorical data, right? We have in smart periods we have ordinal, and we have categorical. But usually categorical is referred to the nominal, ordinal, and scale, and the scale, or continuous. Okay, continuous variable. Here's the important transform non-matrix or categorical data using dummy variable. Okay, but what is dummy variable? A brief idea is that if I have gender as a variable, the value is male or female, or 0 or 1 or 0, right? But for the dummy variable, it means you have to create. It means you create new variable. Let me show you here. Original, the gender, maybe just coding like a male and female, male, something like that. And you have to regenerate to the dummy code. So this gender, dummy. You have transformed the male to 1, female to 0, female to 0, male to 1. Okay, that's one way. It's called dummy regression. I guess based on your project, I don't think you will use a regression. Probably you will use smart SEM. Okay. That's a representative that we have independent variable. It's called continuous, and we have categorical variable as an independent variable. But for the y, so we can see that it's x and y. This is x continuous, x categorical, and this is y continuous, and y categorical. So if we have two x and y both COCO, right? COCO, continuous versus continuous, then we can use regression. But if our y is categorical and x is continuous, then we need to apply logistic regression. There's a simple chart for you, regression. Regression equation, estimate regression, intercept, slope. I just mentioned about that, slope. Okay. Or coefficient, regression coefficient, and error term, right? I just showing that error term is the difference between the regression line and the actual y. Okay, and how to interpret the result? Usually we have to look for a p-value less than 5%. It means significant. We have to check multi-collinearity. Collinearity means high correlation between. High correlation. This one usually focus on independent variable. Okay, not include dependent variable, only focus on independent variable. So if we are between the two independent variable, if the VIF is greater than 10, usually greater than 10, it means we have high collinearity. For example, we have x1 and x2. If the x1 and f2, the VIF is greater than 10, it means the x1 and x2, they have high correlation. Let's say, how about the coefficient is 0.95? It's pretty high. So, it's pretty high. And you have a model looked at x1 and x2. They both influence your y. Now, how do we decide which one influences y? If S1 and S2 have highly correlated, let's say 0.95, they are almost quite similar to the same one. So how do you decide which one influences y? So it's very difficult to clearly describe. So we have to solve this problem. Solve the VIF multicollinearity. We have to solve this one. If we have 10, we have problem. So we have to transform our data first. I will not talk about this one at this moment. So linear regression. Let's take a look the data. Let's use the study of tourism. Okay, we have visitor experience, travel image, and reverse intention. This one. Tourism. Let me see here. And teams. I think we have the data set already uploaded to the. You already used it in previous course. Let me see. Okay, this one. This one. Travel motivation. Not this one. Travel motivation. Not this one. Okay, I think it's this one. It's called second order construct. Let's download this one. Download the week 14 second order construct correlation analysis. Click this one. Download. Okay, download to your computer and open this one with JAS. Yeah, good. Now take a look at the data set here. Yes. There's the visitor experience, ESP, visitor experience, and we have image. IM stands for image. It's a travel image. Then we have reverse intention, RV, stands for reverse intention. So you can see that we have reverse intention. So you see that we have three construct: reverse intention, travel image, and visitor experience. Good. Let's close it. Now first, I would like to show you how to do the correlation analysis. First of all, okay, you can select the regression icon, select the regression icon, and then the first option called correlation. Click here, correlation. Okay. Now take a look at your right hand side. There's pop up a title called Pearson. And take a look. So it's called Pearson, Pearson. The Pearson correlation only for the continuous type. So continuous type. At the left hand side, you can see the simple correlation coefficient. The default is called Pearson. It's called Pearson. And under the Pearson, you can see a Spearman, right? Spearman, or even candle tau. They are for categorical. Alright? Categorical data analysis. So now, because our data set, three concept is continuous, so we will use Pearson, not Spearman or candle taus. Okay, let's do it. Let's move to the button, try to find the variable, three construct. Okay, so I select three construct and move to the variable here. Okay, now we have result on the right hand side. Let me copy here and pass to the whiteboard. I remove it and pass here and make it easy to read. Okay, good. Now I would like you to interpret the result. Alex, how do you interpret the result? We just finished the correlation analysis based on 3 variables. For the visitor experience, travel image, and the release intention. How do we interpret? Alex, how do you interpret? No? No idea? Ready? Set, how about you? How do you interpret? How about the first one? Release intention and travel image. What does it mean? No idea? Okay. Let me try Helen. How about you? What does the Pearson correlation result mean? How about the first one? We have 3, right? Visit, release intention, and travel image. How to interpret the information here? Then what? Okay, so what does that mean? P-value is less than 5%. What does that mean? Not sure. Try. Don't be afraid. What does that mean? We just talk about correlation. Right? Show you the chart, scatter plot. Now we do the analysis in just. And we also talk about the discriminant validity, right? In the previous section. Use the correlation analysis. Anyone? Anyone here? Julie? Interpret the meaning of the first one. The first one, release the intention and travel image. Release the intention and travel image. And we have to construct and we have correlation, right? Have 0.578, right? And the next is called the visitor experience. Visitor experience with the release intention here is 0.681, 0.681. And the last is travel image with the release intention is 0.821. Julie, what does that mean? How do we interpret? You know, we just finished practice in the smart periods. We have create, right? Smart periods. It's the same, just different data set. Positive, how do you know? Good, how do you know?
Because R is larger than 0.
Okay, because of that, the correlation R is positive, right? It's positive, greater than 0, right? Okay, and also the p-value is less than 5%, means the positive relationship is significant. Okay, don't forget, p-value usually have to less than 5%, means significant. Okay? Significant different, significant relationship. So keep in mind. That's the correlation analysis. Okay. Now how about the regression? Let me show you the regression. Go back here. There's correlation. I can close. I can open the correlation. Not correlation. I need the not correlation. I need the regression. This one, okay, it's the same. So I remove. So I only keep one. The correlation is here. So good. So because there's a relationship between three constructs, so then we can move forward to explore the cause and effect. The cause and effect relationship. I mean, we can move forward to see whether or not the visitor experience and the travel image really influence revisit intention. It's called cause and effect relationship. So this is time. So the visitor experience and travel image have to happen before release intention. Okay? But how to do it? We just let me show you. Click the regression. Now select the second one, collinear regression. Select linear regression. Okay, good. Now I want you to do it here. This is dependent variable, and this covariate is your x. Okay, so you need to move the revisit intention here, and move the visitor experience and the travel image here. Okay, it's easy, right? Carly, what's wrong? You smile?
No.
No? Nothing? Okay, good. Now let's do it. Let's from the left hand side. Now select revisit intention and click move to the dependent variable. Now the visitor experience move to covariate, and the travel image move to the covariate. Got it? Got it. Good. Now under the statistic, let's take a look. Model fit, it's okay. VIF, you can check the VIF. You see that? Under the coefficient, we have option called tolerance and VIF. You can check this one. Okay. I think it is enough. Okay, that's enough. So we have three output here. The model summary, the ANOVA table, and the coefficient. Okay. This first one is overall. It's a model. It's a model performance. It's a model performance. Okay. And another table is how is the independent variable has significant effect on the y. So we have called ANOVA table. Okay, I'm afraid we don't have time to explain it in detail. We'll talk about it next week. Okay, so see you next week.